Good afternoon, dear researcher and invited guest. It's my great pleasure to welcome you to the 5th International Conference on Information and Communication Technology for Competitive Strategy ICTCS 2020 virtually on Zoom. We all have been striving hard to fight against COVID-19 and now we are already in second wave of it. We at ICTCS 2020 wish you and your family a very happy and healthy life ahead. Kindly request you to take necessary precautions for your own safety to overcome this phase as well. We at Global Knowledge Research Foundation are thankful to our all guests for being a part of this virtual conference for making it successfully as the previous ones. Hope you will be enjoying the 2 days of interactive sessions. I would want to let the presenter know that they will be given 8 minutes for their entire presentation and 2 minutes for any queries. I humbly request to stick to the allotted time. Now I would like to introduce our session chair, Dr. Swati Nikam. She is an associate professor in Department of Computer Engineering in Dr. D.Y. Patil Institute of Engineering and Technology. She has overall 20 years of experience and also has the experience of organizing 2 workshops. She is guiding students at UG level and PG level as well. Dear ma'am, I welcome you and now I would want you to take this session and continue further. It's all over to you.
Yeah, thank you, Richa. May I start with the first presenter?
Yes, ma'am.
Yeah, sure. Yes. Ankush, are you there? Yes, yes. Ankush Kudare, sir, you can start, sir.
Hello, can you hear me, madam?
Yes, yes.
Yeah. Good afternoon, madam.
Good
Just
afternoon,
I'm
sir.
sharing my screen.
Sorry for interrupt, Ankush. May I know your title, your
Yeah,
paper?
my title name is Cloud Computing and Analysis of Authentication Methods over the Internet.
Okay, I think this is not your session. This is
Okay.
3A.
Okay, this is 3. I thought it's a right. I thought it's a 3B.
No, it's 3A.
Okay, no problem. I will join later. Right.
Uh, and we can announce the name serial wise. The first presenter is K. Rajeshwar. I think K. Rajeshwar is absent. So now we can call up our next presenter, Sahana, modeling and simulation of an automotive radar.
Hello. Yes, ma'am.
Yes, Sahana, you are audible. Just go ahead with the share screen.
Okay.
Yes, sir. May I know, is my screen visible?
Yeah, it's visible. You can just make a full screen. That's it.
Yes, sir, it is full screen.
I am texting you. Inaugural has been completed.
No, in the
So
bottom side, there is a one link
right
of
now I
full
am
screen.
sending
You
you
can
one
do it.
link. I will text.
Right click on full.
Hello, sir.
Yes, yes. Go ahead.
Yeah, is it? Yes, sir. Thank you so much. Good noon to everybody. I am Sahana Punagin from KLA Technological University, Hubballi, Karnataka. Firstly, wishing everyone good health. I am here to present a modeling and simulation of an automotive radar on behalf of co-authors Preeti Pillai, Raghavendra Sheth, and Nalini C. Iyer. I will quickly go through the various sensors on vehicles, radar and its working principle, system design and implementation, details of radar in MATLAB, finally results, conclusion and the references. This is an era of autonomous vehicles, and to make it self-driving in its environment, the vehicles makes use of different sensors like a camera, which is a passive sensor, and active sensors like radar and lidars are in use, each having their own applications. I chose radar for modeling, and it stands for radio detection and ranging. It works on the principle of reflection of electromagnetic waves. Basically, the transmitter emits out radio waves and that strike an obstacle and reflects back to the receiver. We call it an echo signal or the reflected signal. Then, by calculating the direction in which the waves are sent and received, the distance of an object can be detected. Usually two different frequency bands are used, that is 24 gigahertz and 77 gigahertz radar. In this work, it is intended to simulate 77 gigahertz radar because at high frequencies, radar yields a better resolution at lower cost, and also making it simple to integrate on vehicles due to decrease in size of antennas as the frequency increases. Looking into the system design, the block diagram is shown here. It is used to estimate range and velocity of the objects in radar's field of view. The flowchart is also shown in the left side. So for the algorithm, we need to provide a target vehicle environment information like a distance and velocity of detectable vehicles so as to develop a generic radar sensor model. Then there are different modules. Firstly, there is a FMCW generator model. FMCW is a frequency modulated continuous wave generator model, which has a starting frequency of 77 gigahertz. So this wave will be an incident wave on the obstacle. Next is to define a transmitter, receiver, and antenna parameters like antenna aperture, gain of transmitter and receiver, and so on. So as the signal is transmitted in the channel, it hits an object and receives an echo signal. The reference and echo signal is processed, that is, it is de-chirped to obtain range and velocity of the target vehicle. So coming to the implementation of radar in brief, the figure here shows the frequency modulated continuous wave radar. It consists of a synthesizer which generates the chirp, and it is known as heart of the FMCW radar. So chirp is basically a continuous sine wave whose frequency increases linearly with respect to time. So this chirp is transmitted by a transmission antenna, then the chirp is reflected off an object and reflected the chirp is received at a receiver antenna. These transmitted and received signal are mixed, resulting into an intermediate frequency signal. This signal is sent to the low pass filter and it is digitized for further processing. The graph here shows the transmitted signal and the received signal along frequency and time axis. The blue signal is the transmitted signal, so it goes and hits an object, so there is a time delay, and then we are going to receive an echo signal which is shown in the red here for this. It has only one red signal because we have designed it for one target only. If there would be many targets, those many red signals would have appeared. Basically, the chirp is characterized by starting frequency 77 gigahertz here, sweep bandwidth FB, which is the difference in transmitted and received signal, and the sweep time delta t, by which the sweep slope is calculated. So a single object in front of radar produces an intermediate frequency signal with the constant frequency of a slope multiplied by distance by divided by the speed of light. Then the range is calculated as the speed of light multiplied by the time divided by 2. So to extract both range and speed of the target vehicle, the model uses a root music algorithm by computing frequencies and power of sinusoids. So based on phased array system, the radar parameters are considered to be so. The operating frequency is 77 gigahertz with the range resolution 1 meter, and the radar can detect objects within the range of 200 meters with the maximum target speed of 230 kilometer per hour. Next, sweep time, which is at least 5 times the round trip time. So it gives out to be 7.33 microseconds. The maximum beat frequency is 27.3 megahertz with the sampling rate of 150 megahertz. In this experiment, the moving target with a speed of 96 kilometer per hour is considered at the distance of 43 meters. All the simulations are done in the platform of MATLAB using different toolboxes. Phased array system toolbox helps to develop the model of radar transmit and receive hardware. It also does signal processing, object detection and estimation. There is another toolbox, namely automated driving toolbox, and it models the vehicle motion using driving scenario object. To track synthetic vehicle detections, a multi-object tracker is used. So here in the figure shown left, it is the FMCW signal which is varying with the frequency with respect to time axis. It also shows the spectrogram of the same FMCW signal. The image in the right shows the range Doppler graph. So we can see that the object is a little more than 40 meter away, and it appears to be static as both the source and target are moving in the same direction. And the radial speed of the car relative to radar is 4 kilometer per hour, which turns out to be 1.1 meter per second. This is the plot of a spectrum analyzer. It shows the spectrum of each received sweep and also its D-chirp signal. The yellow signal is the received signal and has a wide bandwidth which sweeps through the entire bandwidth. The blue signal here is the D-chirp signal and has a narrow band. Here only one peak is shown there is only one target. This figure shows the ego vehicle and three different targets, and it is simulated using automated driving toolbox. The ego vehicle is traveling at 80 kilometers per hour, and the yellow, orange, and purple are the different targets traveling with 100 kilometers per hour, 110, and 130 kilometers per hour, respectively, all in its field of view. Radars are used in many automotive applications and above all in driving assistance systems. So to make sure such advanced safety systems work properly, it is essential to validate them. So as a part of real-time radar data is obtained using AWR-164 automotive radar, and it is validated in real time within the maximum range of 50 meters. So as to speed up the development of advanced assistance systems, the virtual driving simulation tools are used in this work, and it is projected here. These are few references. Thank you so much for patience listening, sir.
Yeah. Thank you, Sahana, for the nice presentation.
Thank you.
So can you tell me what are the challenges you faced in modeling and simulation of radar system?
Ma'am, sorry, I couldn't hear you.
What are the challenges you faced in the modeling and simulation of radar system? What are the real-time challenges you faced?
Oh yeah, the D-chirped signal obtained would have different peaks when the objects, when multiple objects are being placed. ma'am. So I think finding the peaks would be a little difficult.
Okay, okay, yeah, yeah. Thank you.
Yeah, thank you so much, ma'am.
So now we can would invite our next presenter, K. Rajeshwar. Hello.
Yes, thank you, madam. Thank you for giving me the opportunity. I'm audible to you, ma'am?
Yes.
Am I audible, ma'am?
Yes, sir, you're audible.
Right. Thank you. Just I will share my screen. So this is about the presentation on escalating social justice through effective implementation of e-governance. E-governance, ma'am. The paper is mainly depicts how we have used how the effective implementation of e-governance in terms of the service delivery mechanism, and e-governance provides effective online services to the public and promotes transparency and accountability in procedures, accelerate the response time, and facilitates anywhere, anytime services to them by using the ICT. So here we made an attempt to explain how e-governance is required for exchange of information between citizens, corporate or government departments, helping in increasing revenue, restructuring of administrative process, and providing quality services. And we have also illustrated one case study on the effective implementation of the e-governance map, that is of Lokmani in Sitapur district of Uttar Pradesh state. This is a good system which provides an effective in reducing the number of visits made by public to government offices for availing various types of services. So this whole paper which will talks about the implementation of e-governance and the e-governance, we can also have the paper which also looks about the requirement of e-governance and the implementation of e-governance at national scenario, and success of e-governance in the national scenario, right? And with a case study of Lokvani. Then with a little background of this paper, the government of India took note of the strength of the ICT and strongly proposed digital India, wherein a lot of emphasis was laid on digitalizing the data. It has also led to make people use and have better control day to day day-to-day services and revenue generation through some really efficient service portals. Over the period of years, it has been observed that ICT has brought tremendous benefit to all stakeholders, that includes individual business groups, corporates, and governments. They are now able to customize their needs in accordance with usage of technology. It also leads the data for analytical of decision support system. The people are now more aware about computers and the advantages with that. All the stakeholders, be it with the people or with the government institutions or the society, have recognized that e-governance is essential, and with the use of ICT, a wider participation which can include in nature and deeper involvement of the masses is ensured. So in order to work with the e-governance, the prerequisites are the prerogative is to have the infrastructure is in place. Computerization of workstation is the basic mandate for an efficient e-governance system. A proper online workflow procedure and well-connected systems are crucial. Proper trainings to be imparted to all the government employees, and some awareness can also be provided for the citizens how the system can be implemented and works on. A user-friendly interface assess works process, accessible service to be provided without any complexities. Consequently, the transparency of work being done and thus leads to march towards the e-governance. We have also taken into an account of how the scenario, the implementation of e-governance in India across. So Government of India has developed an action plan that is of, as you are all aware, NEGP, National E-Governance Plan, to implement and roll out the government functionalities and activities through electronically. That means by means of e-governance. Under this action plan, all the services are categorized into 4 models: G2G, G2C, G2B, and G2E also, for providing various types of services. The service delivery mechanism is enhanced from national, state level to local level through citizen-centric and business-centric governance to empower the society and to increase the rural economy, which aims for sustainable development. Under the e-governance plan, lot of activities such as Information Technology Act provides the legal framework for all the e-transactions. A national task force came into existence to look after the IT and software development. In this perspective, e-office is the best case study of application which was developed by the NIC and rolled out in all the ministries for avoiding delay in government functionality. This mainly this e-office functionality, which will be all the office functionality, the file moving system, and even if an employee has to avail the leave management system, personal record management system, document management system, and tour management system, so forth, and even notice board also can be will be developed, will also be there in the e-office system, which can serve all the purposes. And in the government system, by using of this e-office application, there is no delay and we can easily track where the file it is. That means the moment of the file, without knowing and without asking anybody, the sender can see each file movement. Right, so this kind of beauty is there with the e-office application. It is a very transparency and accountability of the government institutions to work on it. And we have also stressed here that e-governance has been successfully floated and executed in many parts of the country. It has a long way to go as more inclusive approach is required. People need to be made more aware and trained. They need to be oriented for making a shift from proper paper mode to digital or electronic mode. A strategic roadmap needs to be designed for achieving the same. This is one of the gap which we have find it out by using this data. This is a secondary data which you are seeing in this table. This is the age group of 14 to 29, 30 to 45, 46 to 60, and greater than 60. This is about the rural area, and this is about the urban area. This is about the male percentages and the female percentages, and in the persons wise, this is the average on this. So this means that more emphasis will be worked out for the awareness and training the people in order to use and in order to get the effective implementation of the e-governance services or e-services to the citizens. This one of the we have also discussed about the success of e-governance in India across the country. Most of the administrative work in India is rigged with the authorization principles which have characterized it as slow and inefficient. It is again reiterated that a model needs to be introduced for doing away with the traditional mode of using paper and embarking on using digital mode. Improving of service delivery mechanism through providing a single window for operation thus leads to enhanced record keeping in a transparent and acute manner. There is a less number of procedural complexity and the process have been considerably improved and become more transparent. E-governance model has yielded good result. To further elaborate this point, we have presented the Lokvani here. They make an attempt to see how effective implementation of e-governance has helped people in grievance readdressal, thus meeting out justice to them.
Dear
The
author,
main objectives.
Dear author, sorry for interrupt. You have last 2 minutes. Please conclude your presentation.
Oh, ma'am. Okay, just give me 5 minutes, ma'am. Just I will complete the main essence. I will complete it.
I can give you last 2 to 3 minutes only.
Okay, ma'am. The main objective of this paper is we have discussed about the e-governance application of Lokvani website and the legal complaints of the fill-in application by the citizen of the Sitapur district. The secondary data we have considered here during the period of 2014-15 and 2018-19 and 2019. The data depicts how the complaints are resolved, disposal, complaints, how the Lokvani website is extensively being used by the public of Sitapur district, thus making it success. This is about, then just I will go with the analysis, madam. Here the data, this implementation status of Lokvani in Sitapur district is execution status of Lokvani project in Sitapur district 2014 to till date. The data is sourced from Lokvani website. Among them, um, 1,52,816 complaints were resolved. However, 1105 complaints are showing pending status. It is also evident that the number of people using this platform has increased over the period of year of grievance readdressal. Though the number of complaints yet to be resolved are high, they have also increased in proportion over the years. This is about the status of the complaints registered. For the last 5 years, legal complaints registered by the citizens of Sitapur district is 2,75,668, in which 2,28,760 complaints are resolved. That means here the people are not visiting the offices in personal. They won't go to the court and they won't go to the police station. Directly, the citizens of Sitapur district will register the complaint through citizen-centric services with the Lokvani portal, and they will get the solution here with this. The author have examined the data for 5 years span, 2014 to 2019. The total number of complaints, 2,75,668, and 2,28,000 were resolved. The authors have categorized the complaint as number of complaints registered, number of applications moved to the next level in 15 days, time period, complaints having difficulty in resolving complaints noted as defaulters. Out of which 16,036 are depicted as normal. That means the complaints are moved to the next level, are resolved within 15 days of time. 8,415 are represented as defaulter, which means that the complaints are not moved to the next level within 15 days time. 22,000 change applications are shown are not marked status, which shows that the applications are not filled properly. It can be interpreted here that awareness campaign is required for the people if more participation of public is sought in order to submit the application correctly in the Lokvani. Here the main thing is the relationship between the disposal complaints and total complaints done is a positive, high correlation. We have tested the correlation here, which is of 0.94. That is, disposal and complaint resolving are going on in parallel and stand significant at a 1% level. For the last 5 years, overall, 17.90% applications are pending in Lokvani, which is very few small percentage. This shows that the citizens of Sitapur districts are extensively using the Lokvani portal for registering the complaints and believe that the complaints will resolve at the earliest and in time. Lokvani grievance and petition services. Citizens who are registered users on Lokvani platform can log in and track the petition from nearly a kiosk and see the status by using any of the mode like IVRS and SMS mode. Color coding helps in knowing the status. In turns red when the due date expires and finally turns green when it deals with and disposed. The process
Dear
of
presenter, please
Lokvani.
conclude your presentation.
Yeah, thank you, ma'am. I'm concluding my presentation. As per the Lokvani, the services are catered to 3 stakeholders, namely citizens, administration, and kiosk operators are the small scale enterprises. An innovative step was taken wherein the existing cyber cave were identified and turned into franchise centers. This leads to making the model quite self-sustainable. It was also ensured that any kind of operational support from government would be avoided. Own source funds were created and that led to payment of the kiosk operators. As the system is pretty transparent, bottleneck were overcome in the system, thus increasing the non-performance to pull up their socks. The authors also opinion that the Lokvani project has brought into a paradigm shift leading to an effective, transparent governance system. A common man who is rigged with poverty struggles with the challenges of illiteracy and economic constraints can also get access to justice. As expressed through the example of Sitapur, the model has emerged as successful one and overcoming all detracts. As acknowledgeable takeaway from this project is raising awareness among the masses through persistent and focused campaigning for its effectiveness in harboring change. Thank you, madam. I thanks for giving me this opportunity, and it's open for any questions also. I'm very much thankful to hear something from your end.
Yeah, thank you, Rajesh sir, for the presentation. My question is now the case study which you have presented is showing all the favorable conditions, but this may not be applicable for the other case studies. Like, so can you just elaborate what may be the impediments in the effective implementation of the system?
Ma'am, one thing, in India, why we have taken only this Lokvani as a case study for this because why we have selected this Lokvani. That means here, ma'am, comparing to all the e-governance projects, Lokvani is different kind of it. The Lokvani is like a grievance redressal system. Automatically it will be the petitions or the issues will be noted down here. So the government of India, they have started the pilot project in the year of 2014, and from that the district magistrate, the IS officer was very much keen interested in implementing this Lokvani project at that stage, and they have for sustainable mode, they have taken into the kiosk into the system, and by providing it. And this type of Lokvani project, not in the except Sitapur district in Uttar Pradesh, nowhere it was being implemented. This was a unique model of the Lokvani map.
Okay. Yeah. Thank you, Rajesh.
Thank you, ma'am. Any
Now we call our next presenter, Snehal.
Good afternoon. Ma'am, is my screen visible?
No, Snehal. Yes, please start the presentation.
Is it visible now?
Yes.
I'm not able to see now.
Can you just double click?
You can just stop your share screen and again you can do the share screen.
Yeah. Is it visible now?
No, yet not.
So I have started the screen sharing. Shoot.
Yes, go ahead.
Okay.
Make a full screen and go ahead.
So where is that option?
In the bottom side, yes, perfect. Otherwise, click on function F4 or F5. Yeah, okay.
Okay. Good afternoon, everyone. I'm myself Snehal Dogre. I'm presenting my paper on implementation of different methods. Yeah. Hello.
Nothing, go ahead.
Yeah. Implementation of different methods for decomposing the rhythms of EEG signal. Okay, so here, as we know that our brain signal consists of is used for conveying the different conditions like psychological conditions, like whether the person wants something or he want to convey something. So different psychological conditions can be conveyed with the help of the brain signals. So in order to convey these brain signal, we need to acquire the brain signal, and these signals can be acquired using the various sensing mechanisms like EEG or MEG. But we know that the out of all the available method, EEG is more suitable because of the its cost, portability, and other medical reasons. Okay, so EEG signal that reflects the brain condition is basically a group of the frequencies that is ranging from the zero point 0.1 hertz to the 64 hertz. These different bands of the EEG signal is used for reflecting the different mental activities. Okay, so if we want to take out the some information related to the particular mental activity, we have to separate out a particular band from the EEG signal. Okay, and moreover, if I want to remove the noise associated with the EEG, then also we need to find out in which of the band the noise is associated with. So in our paper, we focuses on the different methods for separating the EEG signal rhythms or decomposing the EEG signal rhythm. In this paper, we have used the methods like temporal filtering, wavelet based filtering, and empirical mode decomposition. Okay, so yeah, I will go to this slide. As I said, that EEG signal um is the group of the frequencies. Okay, so EEG, particular EEG signal consists of these band delta, theta, alpha, and the beta is separated into the low beta, mid beta, high beta, and the gamma. So these are the various frequency ranges, and each of these frequency range indicates the different mental activity, like delta indicating the deep sleep, theta indicating the dreaming condition, alpha is quite for the relaxed and alert, then the beta is associated with the thinking and alertness even, and the gamma is related to the motor function and high mental level activity. So for this EEG can be beneficial for the person with the disabilities, who cannot perform its own action, and we can ask that particular patient to just think about the particular activity. Okay, so if I say think about the particular activity, then we have to focus on the beta frequency, so I will be taking only the beta. If we have to find out the sleep disorder, then we have to focus on which band? Delta band, because the sleep is associated with the delta. So like this, just we have to find out the particular mental activity, and then we have to separate that band and work on that band. If we work on that particular band only, then we will be getting the good results. Okay, so that's why our focus is to separate out that particular band, because to reveal the information from the EEG signal, we need to separate that band, because as I just said, it particular band focuses on the particular mental activity. So as I said, our our aim is to separate out the bands of the EEG signal, and this can be separated using the various methods like temporal filtering, empirical mode decomposition, and discrete wavelet transform. Okay, so why we have considered all these different methods is that temporal filtering, we just take an entire signal and filter it out. But as we know that the EEG signal is very dynamic and non-linear, so we have to consider the both the information, that is the time domain and the frequency domain. So instead of focusing on just the temporal filtering, we then move on to the next filtering, that is the wavelet transformation, in which we take into the consideration both the time and the uh, frequential information. Okay, so both the features can be extracted, and we get the more information. But it is also said that the EEG signal is a dynamic signal. It means that the frequencies also changes with the time, so the wavelet is not that much helpful in that case. So we have to consider the another method, and that is the empirical mode decomposition, in which what happens that we focuses in which the dynamics of the frequencies are taken into the consideration. Okay, so for the entire time the frequencies can change over and it can be detected. So yeah, see here, as I said, because in the EEG, if we want to find out the particular mental state, the basic steps involved are EEG signal acquisition, signal decomposition, feature extraction, and classification. So in all of these steps, the second step, that is the signal decomposition, is very important. And if we focus on the second step, then the accuracy of the detection, that is mental state detection, increases. Okay, I have tested on it for my further results, and I found that if I go for the empirical mode decomposition for separating the band, the accuracy exceeds to the 99%. Okay, but the aim of this paper is only just to show that how the decomposition is done. So the yeah, we will be focusing on the second state, that is the decomposition, and it is done using the three different method. Temporal filtering is used. So in this, what we have done, temporal filtering, we just use the bandpass Butterworth filter, and as our diagram says, this table says, we have taken into the different bands, and the different bandpass Butterworth filters are applied for getting the main 5 bands of the EEG, that is delta, theta, alpha, beta, and gamma. In this, we have separated the EEG signal. Okay, so another thing, as I said, the data set we are using for this is having the sampling frequency of the 5 and 2 hertz. So we have used the 8th level of the decomposition in the wavelet transform using the Dobbich's 4 dB4 wavelet. Okay, so if we do this, we can separate out the EEG signal into the different bands like delta, gamma, beta, alpha, and theta. Okay, again, the 3 other uh, coefficients are available, that is having the frequencies ranging in the range of the 63 to the 500, but this is of no use for us and it becomes a noise. So we will be only focusing up to the D4. Okay, D4. Okay, so this is what. And in the empirical mode decomposition, the decomposition is done into the intrinsic mode functions, where we find out the instantaneous frequency for each for the given time series. Okay, and we can find out the effectiveness of each of these method by applying the or by taking the power out of the each of the decomposition. Okay, so as I said, the data set used for the experimentation is available at the OpenVibe uh, on the OpenVibe site, and the dataset consists of the imagination of the left and right hand movement of a particular user, and is being recorded by the Mind Media Nexus 32B amplifier, and the sampling frequency is the 5 and 2 hertz. The total records is the 20 for the left and 20 for the right. Okay, so this is my raw EEG signal that I have been taken, and if I want to find out the frequencies, then I applied the filtering. Okay, so temporal filtering applied over here, as I said, delta, theta, alpha, beta, and gamma we get out of this. Okay, so these are the results for my bandpass filtering. That is my temporal filtering. Then I can apply the 8th level of decomposition using the DB4. It is showing the good result. So I applied it again. I get the same frequency bands because this we require to separate out, and I get this somewhat showing the better. And then I can also do the band decomposition, and I get the EMD out of this. Okay, so the conclusion is that this paper explores the different method for separating the EEG rhythm, and we can automatically decomposes the EEG into the various EMD is found to be the better if we find out the power in that, since it supports the non-linear and the dynamic behavior of the EEG signal. Hence, the detection of the EEG or the mental activity can be done properly. These are some references. Thank you.
Yeah. Thank you, Snell, for the presentation. Now, can you just tell me,
Yes, ma'am.
am I audible?
Yes, ma'am. Yes.
Yeah. Okay. So, can you just tell me, like, how would you compare it with the means? What could be the disadvantage of this method? Like you have used it, you have given the advantages also as compared to the other methods practically. I mean, theoretically you have explained, that's fine, but practically how could you compare it with, means what could be the drawbacks of this method?
Ma'am, in this the empirical is a good one, okay. But if we just go for the temporal filtering, in that case, as the EEG signal changes with the respect to the time, then the activities cannot be properly detected, and hence the accuracy of detection. Like if I say, if I think that move the left hand, but it will not detect properly. Okay. Even in case of the wavelet transform, if I decompose that band, since what is happening that it is not taking into consideration all the features out of the EEG signal, that is temporal and frequential feature properly, hence the detection activity degrades if we consider the temporal filtering only for decomposing the band.
So any other better effective method you have studied or you have come across?
Ma'am, I
It
came
would
across.
actually or accurately depict the movements.
Ma'am, I have studied all these three methods and applied three methods for extracting the different features and then classification using the SVM. So I found that empirical mode decomposition is the best one out of all. Empirical mode decomposition method.
Okay, yeah, thank you, Sneha.
Thank you, ma'am.
Now I would like to invite our next presenter, Navneet Kaur.
Yes, ma'am. Am I audible?
Yes, Navneet.
Good afternoon, everyone. I'm Naneet Kaur from Jaipur Institute of Engineering and Technology from Patiala. And over here, I'm here to present my work, that is hardware implementation of English to regional language translator using Arduino. In present scenario, English has become a global language. It is spoken in every nook and corner of the world. But there are still many people who only know their regional languages rather than English. So such kind of people, they face problem, like when they have to read the instructions in the public places, such as at railway station or airport. So to overcome such a problem, we really require a help desk that convert English language to the regional language. So, but this system has to be economical and durable at the same time, but not at the cost of memory and power to which it will be connected. Now, this is the block diagram of the system. For this, the language translator will require a keypad, a push button, a Atmega 328 microcontroller, a communication protocol, that is SPI, through which data is communicated from one controller to the another, and finally a liquid crystal display on which the regional language will be displayed. In this paper, we are going to present the regional languages on Hindi and Punjabi. So for knowing about the system that is being presented over here, we need to learn about two things. One is Arduino Uno, that is the controller used in the system. And the second is the SPI, that is Serial Peripheral Interface Communication Protocol. Initially, we'll go with the Arduino Uno. Arduino is a board that contains Atmega microcontroller, SRAM memory, flash, and EEPROM storage. It is, for example, you can see over there in the figure 2, this is the Arduino Uno board. There are different type of Arduino boards like Uno, Mega, Nano, but over here only, but these are differentiated based on the number of analog pins, digital pins, type of microcontroller used. But among all of these, Arduino Uno we have selected because it is the cheapest one and it fulfills all our requirements for the language translator. As you can see in figure 2, on the right side, these are digital pins, left side, these are 5 analog pins. And this is in the center, it's a microcontroller and it contains USB plug and power supply as well. Now, this is the serial peripheral interface. it's the communication protocol. In present times, there are different types of communication protocols used, such as I2C, UART, CAN, SPI, but among all of them, we have chosen SPI owing to its many advantages. First one is that it is full duplex, it works in full duplex mode. We can transmit and receive data simultaneously, which is not possible in I2C. Moreover, in this, we have single master and multiple slaves. Means in a scenario when we want to communicate data from one master and to represent the same English language data to be represented in Hindi, Punjabi, Bengali, it can be done through an SPI, a communication protocol, which is not possible in another protocols. Now, and these are the 4 pins that are used in SPI. First is synchronous clock to synchronize the master and the slave. Then is MOSI, master output, slave input. Then MISO, master input, slave output. Then SS, slave select. Slave select is used when we have multiple slaves. For example, from master, we want to select which slave, like 1 number, 2 number, 3 number. At that time, it is used. Now, this is the flow chart of our proposed methodology. Initially, we just type the text in English from the keypad. And then to attach, there is a push button. In this system, in the presented system, it will be like this, that if a push button is pressed once, the Hindi lookup table will be selected. And if pressed twice, then Punjabi will be selected. Now, what is in the lookup table? These are just corresponding characters to the English language that we have designed so that we can get the regional language conversion after it. So after these from English to lookup table corresponding characters has been assigned, the text is sent to the slave, to the another Arduino, slave Arduino, through communication protocol, that is SPI. And finally, we'll have the output on the LCD in Hindi or in Punjabi, whichever language we have chosen from the push button. Now, there is a problem, like in the keypad, there are only 16 characters, but in Hindi and in other languages, we have more than like 30 or 40 characters. So for that, this is the reference phone, like not in like present QWERTY keypads. We used to have like on 2, we have ABC. We just used to press A, then simultaneously we'll get B and C from the same button. So similarly is such a scenario in our system. In the keypad, like if one is pressed 3 times, like if one is pressed once, then A and corresponding Hindi character will be K, and if pressed thrice, then C, corresponding character N, and Sir in Punjabi, it will be selected. And between 2 press, it should be like 0.5 microseconds. Otherwise, the cursor will go point to the next cursor. Now, these are the hardware connections between our 2 Arduinos and the device, so that any layman who intends to make this system can easily make that. And for these are the hardware connections and the pin assignments from Arduino 1 to Arduino 2 and another device. And this is the same case with the keypad and with the Arduino 1 and the other device. These are the experimental details. The coding has been done in Arduino IDE, that is an open source, just to make it more convenient so that anyone can do the coding in it. Now we can, as you can see in figure 5, we have displayed the swagat, that is welcome, in English, and displayed on the LCD. You can see that on the left side it's keypad. The one is master Arduino and the second one is slave Arduino. One is the push button that will decide which language will be chosen. And when we have just sent the data from welcome from the keypad, it is sent from master to the slave, and finally we get the output as in Hindi on the LCD. And in the second case, in figure 6, you can see Swagat, it is written in the Punjabi language, that means same, the welcome. And these are the resultant analysis. As I talked earlier, that the proposed system, the language translator, has to be economical. Otherwise, it will not reach to the masses. That is the main aim of it. The system that has been proposed, it just cost rupees 1800, and its memory is just 4 KB. That is, if a system is attached to any other system, it will not occupy much more memory. Moreover, the execution time for the conversion is just 0.3 to 5 microseconds. That's why it makes the system to be more economical, durable, portable. Moreover, the Uno has been chosen, Arduino Uno, the controller that has been chosen because it is robust in nature. And the main advantages of this proposed system is that it is cost effective. These are economical. Moreover, all the components that are used in this system are available in India. These are not to be imported from any other country. The cross price that has been mentioned is just about one system. If you go further in bulk, you'll automatically reduce the amount as well. In future, if someone wants to rebuild this translator and work further on it, one can make use of n number of regional languages so that it will become multilingual at the same time. For example, on one LCD, it is showing in Hindi and Punjabi or in Bengali. And in another, if we go furthermore, if one wants to work in IoT at the same level, make this project to the advanced version, one can go for cloud-based application language translator so that it can provide security as well at the same time. These are the few references that has been used in the presentation. Thank you very much. And I'm really thankful that you have given me a chance to present my work in your presentation.
Yes, thank you, Navneet, for the presentation. I have a question.
Yes.
First question is to what size it will do the translation? Means because you are referring a lookup table, right?
Yes, ma'am.
So you have the predefined keywords, right?
Yes, ma'am.
Okay. So is there any size limitation?
No, ma'am, there is no size limitations because when the data is sent through the communication protocol, it is sent through 8 bits, means 1 byte, 1 character. So we can send number of characters as we want. In fact, I have just added a space, corresponding space as well. So that because when we talk or when we send a message, there's always a space in between. So I have in fact added space as well, just to make it more convenient and reliable.
Okay. Yeah, fine. And one more question is you have, as far as my understanding, you have considered the translation as per the syntax, right?
Yes,
how would you consider the semantics into it? The English word of fool is different in Hindi. The meaning will be different. No? So,
ma'am, to that, actually the characters has been chosen according to the fonts that are available in the market.
Oh.
So that we can just make it to like that. For example, in the I have chosen a Kruti Dev. I have tested it in my system, like in the Kruti Dev, and over there if I type like PHOOL, it will get fool like that. I have tested in that way because the designing of the fonts that are available in the notepad, they consider all these things, and from that I have taken the lookup tables so that it will be convenient and it is more testified than us.
Okay, but additionally, as far as semantics, you have not considered anything.
Ma'am, it's considered in that lookup table by the fonts only.
Okay.
I have actually tried many fonts, and the best one that I have got that consider all the things, and that has been chosen. And lookup table has been designed according to that font.
Okay. Which other fonts you have tried?
Ma'am, I have tried. Ma'am, actually of Kruti there were like 01, 01, 00. There were different type of versions. But according to a person, that sometimes we just want to have like welcome simple in Hindi, and sometimes we want to go further into Sanskrit and like that. According to that, I have chosen different type of fonts.
Yeah. Okay. Thank you, Navi.
Thank you, ma'am.
Now we can call our next presenter. Our presenter name is Chik Amid. I think this presenter is absent. So now we can move ahead to our next presenter, Chinmay.
Hello, ma'am.
Hello.
Yeah, can you hear me?
Yes, Chinmay.
Yeah, I'm facing a bit issue with screen sharing, so my colleague Samip will share its screen. Yeah, Samip, you can share.
Okay.
Yeah. Yeah, so hello, ma'am. So today we'd like to present a paper. The paper title is Pneumonia Detection Using X-ray Images and Deep Learning. So basically, the aim of our paper was to detect the pneumonia which causes a lot of severe diseases with patients using the X-ray images that we get using the deep learning approach. So we have followed a convolutional neural network. We have used convolutional neural network for our project, and and I'm going to explain that in further detail. So next, so introduction. So as you know that pneumonia is a disease that causes inflammation in the lungs and is caused by bacteria, fungus, or virus. And pneumonia, like, it doesn't distinguish between the age group of a people. It can happen to all age groups, and especially it happens to those people who smoke a lot and those who have relatively a weaker immune system. Some symptoms of pneumonia include a shortness of breath, weakness, and shaking, chills, and fever. So, for example, in United States of America, 1 million patients suffer from each autumn, and about like from pneumonia. And pneumonia is also the eighth leading cause of death amongst the elderly and the infants. So it's quite a severe disease. In order to tackle this, we thought that the X-ray images that the doctors have, or that doctors get of the chest, then we thought that we could analyze those X-ray images and detect if a person has a pneumonia or not at the early stage. So, like, yeah, there are various advantages of detecting pneumonia at an early stage. So by detecting at an early stage, we can start a treatment early, or we can cure some or we can detect early symptoms and cure it more rapidly instead of it becoming a severe in future. So that was our motivation for this project. Next slide, please. So yeah, so the problem statement is simple. So we use X-ray images as a data set, and we feed that X-ray images in our in our proposed CNN model, and the output is either yes and no. So either if a person has a pneumonia or not, or doesn't have a pneumonia. So here you can see two images, showing the X-ray images, the condition. The left one is the normal condition, normal X-ray, and the next one is the pneumonia condition. So the data set which we have used is the Kaggle data set, which has been publicly available. So I'll explain the distribution of data set in the later stages. So next, please. So yeah, the research gap. So the research gap of our project was, like, there are many approaches available on this particular problem, but but mainly those approaches are using CT scans rather than the X-rays image, which are CT scans, which are like easily produced. So we try to do using the X-ray approach. Then the current methodologies use similarity index between X-ray images of patient and previously diagnosed patients. So this point basically means is that it uses the past history of the X-ray images which of the patients which already have pneumonia, and try to learn from those images and come up with them and improve the model. So, and the third point is the higher accuracies achieved by current methods will rely on X-rays of the small data set. So this is the thing which we have implemented. Our data is like relatively small compared to the other data set, other image data set, and it has been working quite good on the small data set. So in future, suppose if we want to improve the model, then our scope would be to extend this further on larger data sets. And by using of course, by using deep learning, it's computationally very heavy and on using on images. So even that's the area where we want to reduce our time and make it a bit optimal. So yeah, next. So yeah, let me first introduce to convolutional neural networks. So what convolutional neural networks are? Convolutional neural networks are basically a deep learning approach, which deep learning it is used for deep learning purposes and achieve higher accuracy rather than the traditional machine learning models like linear regression or logistic regression. So the advantage of using CNNR is like they have a deep network among each other, and the iterations happen at a lot higher rate than the normal machine learning models. And the convolutional neural networks also follow a hierarchical or a funnel-like model, which gives an output which is fully connected to all the neurons. So, and convolutional neural networks also consist of various other layers, like the convolutional layer, the fully connected layer, dropout layer, or the dense layer. So, for example, the convolutional layer is considered to be the first layer of the CNN model, and the convolutional layer, along with a filter of a filter matrix, it like scans each and every convolutional layer basically is like divides an image into a matrix in a matrix form, and it also uses another matrix which is called as a filter matrix. So with the help of filter matrix, it passes that previous information on the next layer. So that's how convolutional layer works, and it also uses various activation functions like tanh, ReLU, or sigmoid. Then the next layer, suppose, is the pooling layer. Pooling layer basically what does is pooling layer there can be a multiple type of pooling like max pooling, average pooling, or some pooling. So basically we get the input for the pooling layer is a matrix which you get from the convolutional layer. So suppose for a max pooling layer, it only takes the max value in certain sections of the layer of the matrix and passes it forwards. So that's the job of the pooling layer. Then dropout layer. Dropout layers are used to reduce the used to reduce the overfitting problem which occurs during deep learning. So it randomly drops out some layers which are not important and which might cause overfitting in the future. So in the next slide, you'll see like a basic architecture of a CNN model. So we can see the convolutional layers, pooling layers, then the fully connected layers, and the output. So next I'm going to explain about our proposed model which we use for this project. So next slide, please. So yeah, methodology. So as I mentioned, the data set which I used was the Kaggle data set, which was publicly available, and it was also a relatively small data set. So it had 5,856 images, and the images were divided into respective classes like the normal images and pneumonia images, and those two classes were further divided into test, train, and validation data sets. So the normal image folder had three images of train, test, and validation, and even the pneumonia had train, test, and validation. And the count has been given in this data has been tabulated in the next slide. Okay, yeah. So
dear presenter, you have last 2 minutes. Please conclude your presentation.
Yeah. So we of course we need pre-processing of the data. So like we use three parameters for pre-processing: rescale, zoom range, and vertical flip. So next slide. So this is our proposed architecture. So we used 5 layers of convolutional layers. The first layer was the convolutional 2D layers, and the next 4 was the separable convolutional layer. And they all had batch normalization between them. So batch normalization was used because like suppose the range of some images go beyond a particular range. Like suppose if there is an outlier or something. So to reduce that, we use normalization techniques. Then we had dropout layers as well. So and at the end we had a flattened layer which connects all the matrix, and after that flattened layer we give the output to the sigmoid function. Sigmoid function was used because sigmoid function is an output of 0 and 1. So as we required in this approach. So yeah, next slide. So yeah, this is the description of everything. Next, please. So hyperparameter tuning. So we used 10 epochs for our training purpose, and the batch size was also 32, which was accurate for this type of data set. And to achieve better accuracy, we tuned our model for input image size of 3 parameters. The 3 dimensions which are considered were 100, 125, and 150. And we after training on these 3 samples, we concluded that the image size of 125 was the best, which has been shown in the result section, which will come later. Next, please. So yeah, the output, as I said, sigmoid function was used. Next. So yeah, so these are the results. So the on the left hand side is the image size, the three image size which we use: 150, 125, and 100. And the train accuracy, test accuracy, recall percent, and precision are given in the tabular form. So as you can see, the test accuracy for image size 125 is the highest that we achieve of 91.185%, and also the recall value of 97.43%. So next. So these are the confusion matrix of of various image size. So this is for our model performance for confusion matrix of image size 150. Next, and these are for 125 and 100. So we achieve the best performance at image size 125. Next. So yeah, so in order to conclude, like our proposed CNN model successfully solved the problem of data imbalance by data augmentation, and we developed a CNN architecture which, under the best conditions, achieve a test accuracy of 91.185% and recall of 97.43%. The CNN model accomplished the primary goal of reducing false negative cases, which are like the cases which the model tells us that we don't have pneumonia, but we actually have pneumonia. So those are the false negative cases which we accomplished to reduce them. Then the proposed model also have low memory and computational requirement, making it suitable for mobile settings. So it wasn't that computational heavy, and we could train a model in 1 hour of each iteration. So yeah, next. So these are some notable references that we used for our model for project. Next. Yeah, thank you. Thank you, ma'am. Any questions if you want?
Yeah, thank you, Chinmay, for the presentation.
Yeah.
Now, what could be the false acceptance and false rejection ratio in this scenario?
Ma'am, we have actually we have that in a tabular form in our research paper. So I'll just tell you. So the false negative cases of the best model which we achieved, that was for 125, was just 1.6%. Like, so out of 100 images, if you take, only 1.6 images would turn out to be false negative. Like, they would falsely predict that you don't have pneumonia, but you actually have. So that was our percentage of false negative cases. We did and false positive case, if you see, then they are 45 out of a total of 600 images. So it's not it's more than false negative case, but that condition can be compensated, because like it's false positive cases are saying that you have pneumonia, but actually you don't have. So it's better than to not have, and it's better than to have pneumonia and the model is predicting that you don't have. So we try to reduce that.
Any possible approach you have thought of for minimizing this acceptance and rejection?
So yeah, in the future scope, actually, we are planning like to further decrease the false negative case. So that could happen, like more hyperparameter tunings. We could like try the, like for example, right now we took for image size 125. We can further try for different image size. Also the data augmentation, we can try more parameters. Like we just use 3 parameters for data augmentation. We could try more for that. So by doing that, I think the false negative case can be further reduced. So that can be the future scope of the project.
Okay. Yeah. Thank you, Chinmay.
Thank you, ma'am.
Now we can call our next presenter, Lynn Tom. Hello.
Am I audible?
Yes.
Is my screen visible?
Yes.
Respected chairman of this session, participants, a warm good afternoon to all. I am Lindstrom, Associate Professor, Assumption College, Autonomous Changanasheri. Title of my article is Dynamic Time Slice Task Scheduling in Cloud Computing. contents of this presentation are introduction, parameters, role of task scheduling, proposed method, experimental results, conclusion and reference. Introduction. Cloud computing is a leading technology that brings up a pool of computational resources with extendability and employment of these as a service through the internet. Cloud computing provides a paradigm for accessing and managing resources based on a pay-on-use model. And task scheduling in cloud computing environment, task scheduling is allocating user tasks to appropriate computer resources so as to minimize execution time and cost. And these are the different parameters for comparing scheduling algorithms. The parameters are make span, execution time, processing cost, throughput, resource utilization, load balancing, waiting time, deadline, priority, energy consumption, quality of service, context switch, etc. The role of task scheduling is that the intention of any scheduling method is to minimize make span, execution time, waiting time, energy consumption, cost, and to maximize processor and resource utilization, throughput, and quality of service. The make span is the most important criteria which determines the efficiency of a scheduling algorithm. It is the total of the execution time and the waiting time. For a specific processor, make span can be reduced only by reducing the waiting time. The heterogeneity and the dynamic nature of cloud systems make the task scheduling more complex. In the proposed method, we propose a dynamic time slice of round-robin scheduling algorithm. In the round-robin scheduling method, the system performance heavily depends upon the selection of the time slice. If the time slice is big, response time will be large, and if the time slice is very small, the many context switch will occur and will invariably lower process utilization. The selection of the time slice depends on the task size. In the proposed scheduling strategy, the matrices under consideration are the waiting time, the response time, and the number of context switches of the task. The method is the dynamic time slice round robin. The step one is it will calculate the average burst time of the waiting task, and it will be split into different queues. And the time quantum for each task is assigned by comparing it with the time quantum of that particular task with the average burst time of the task. And the task will be then run on the available virtual machines for a time period equal to their assigned time quantum. So this is the dynamic property of the round robin method which I have implemented. So the experimental results. Simulation is performed for first come first served algorithm, round robin algorithm, and also dynamic time slice round robin method. And the testing is done with 15, 20, 25, 30 and 35 number of tasks with varying burst time. The homogeneous virtual machines are used to execute these tasks. The set of tasks are randomly generated, and it is assumed that their arrival time is 0. And the simulation is done with 2 virtual machines and 1 virtual machine. The first parameter considered is the average waiting time. Here the average waiting time of first come first serve and dynamic time slice round robin is almost equal. DTSRR, when compared with the RR, the efficiency achieved is 8% and 6% respectively for 2 VMs and 1 VM. When we consider the average response time, the average response time for round robin is lower than FCFS and DTSR by 5% because the time slice is very small. Then the third parameter considered is the number of context switches. And the number of context switches is smaller for DTSRR, and the efficiency achieved is almost 8% for 2 VMs and 1 VM. Conclusion. In the proposed algorithm, we try to reduce the number of context switches and waiting time while keeping the response time on an average. The average time a task wait in the ready queue gets decreased, which in effect reduce the turnaround time and make span of the system. By minimizing the number of context switches, extra time taken by the processor for switching the task can be used for processing. By considering all the matrices, the overall efficiency achieved by the proposed algorithm DTSRR is 11% with the 2 VMs and 10% with the 1 VM. These are some of the references that I have used. Thank you.
Thank you, Lindstrom. So can you, yeah. So can you just tell me, like, what would be the limitations of this proposed method? Have you come across any theoretically, at least, or practically?
There are a lot many parameters there to calculate the scheduling values of a different algorithm. Here I have used only 3 parameters, that is response time, waiting time, and context switch. And the number of tasks considered is maximum is 35, and we are not getting any real-time parameters for calculating. Only simulation is done in using cloud sim platform. No real-time values are not used here. Only simulated values are applied for calculating this value.
Okay. And have you done any comparative analysis of this proposed method?
Yeah, I have compared that with the first come first served and normal round robin value. The 2 algorithms are compared with my dynamic time slice round robin.
Apart from these 2,
by considering this, I have come across a 8% of efficiency for my algorithm when compared with the round robin for average waiting time. And for context switch also, the overall efficiency when compared all the 3 parameters, that is almost 11% efficiency I have achieved by applying this dynamic time slicing.
Okay. Yeah. Thank you, Lynn.
Okay. Thank you.
Now we can call our next presenter. It's Grisha. Lane change assistant using LIDAR for autonomous vehicle. I think Grisha is not there, so we can call our one presenter. It's Cheek Ahmed.
Hello, everybody. Are you hearing me?
Yes, you are audible. Go ahead.
My name is Sheikh Ahmed.
Sure.
I come from University Naziboni. Are you hearing me?
Yes, you are audible. Go ahead, Chi.
So today my work, this work pattern is strength line detection with off transforming on a rectangular grid. The off transform is the method of detecting geometric shapes such as straight lines, circle, ellipse, and other several parametric shapes. This method has improved by Duda and Sere and other several authors in the times. It has experienced improvement over time because its first version did not allow the detection of vertical straight lines and geometric shapes other than straight lines. The implementation of the Hoof transform such that straight lines detection require a lot of computational research and also a significant computational time. And if we consider a digital image with contains straight lines, all areas in this image are not straight lines. Implementing the Hoof transform to the pixel coordinates in these areas is a waste of resource and a waste of time. Our method main goal is to reduce the detection time. For this, we use the following step. If we take a digital image, we can consider like such as matrix. We do a rectangular matching in the image, and we select the rectangle of area or areal. We have a pixel superior greater than alpha. The recognition of straight line in the image with the selected rectangle is done by a data accumulator. An image is a visual or mental representation of an object. It can be modeled in matrix form. For create virtual rectangle matching, we use algorithm 3. The algorithm is presented here. We select the rectangle which will contain some eventually straight lines with the algorithm 4. Data accumulator is a matrix which contains the shape parameter detected by Hoof transform method. The data accumulator needs a lot of research for computational time, and good computational time. It was been optimized by Siri and all. The maxima in the data accumulator indicate as the presence of straight line and the straight lines and the eventual straight line position in the digital image. Algorithm 8 summarizes our work by doing straight lines detection with data accumulator. We applied our method with Ouagadougou city GPS map and 80 as a threshold in the maxima presented in algorithm 6 to do the straight lines detection. So here we have Ouagadougou, an Ouagadougou area GPS map, and we pretended this GPS map with kind filter operator, and we applied our method and make straight lines detection. In this map, straight lines is the road on the map. Table 6 present result. Without our method, the applied of Hoof transform like that all version. If you see the detection time, is greater than all detection times present in the table 7. In the table 7, we vary alpha value to have to values the number of selected rectangle. We remark that we have endless detection time than old method. Conclusion and further work. The presented method reduces the time and the size of the data accumulator, and therefore the time to detect straight lines. However, the thresholds of the accumulation matrix play an important role in the detection of straight lines. The study of its influence on the detection of white is a further study prospect. Also, with prospect to combine the proposed method with deep learning techniques to carry out the discrete straight line detection in important quantity of image. To extend the proposed method to another geometric shape recognition, such as circle, ellipse, or another parametric shape. Thank you very much for your interest.
Yeah. Thank you, Amit, for your presentation. So can you tell me like any other comparison you have done of your proposed method? Any comparative study?
Yeah. We make the comparison with all the transfer method implementation. We don't make comparison with statistical or probability detection methods. But we can do we work in the other method. We use triangle method. We will do a triangular matching, and we for detection of the straight lines, and we want to compare the triangle detection time and like rectangular detection time to do the comparison and know who is better in detection time.
Okay. Yeah. Thank you, Amit.
Thank you.
Call up our next presenter. I think Grisha is there. Hello.
Girisha, you are able to listen?
Yes, sir.
Yeah, you can just go ahead with the presentation. As
Okay,
you
sir.
6 minutes, as we are already delaying the same presentation, so you have a 6 minutes. Start it.
Okay, sir. Thank you.
Girisha, you are facing some issue?
Sir, is it visible? My screen is
Yeah.
visible.
Yeah, it's visible. Go ahead.
Okay, sir. Thank you. Good afternoon, everyone. This is Girisha HM, Assistant Professor, KLE Technological University, Vidyanagar, Hubballi. I am going to present the work we have done related to autonomous vehicle. The title of the paper is Lane Change Assistance Using LiDAR. So the presentation includes introduction, objective of this work, and a architecture and platform, hardware specifications, algorithm and flowchart, and experimentation results with conclusion and few references related to this topic. So let us introduction about the autonomous vehicle. Nowadays, in the 20th era, we are moving to from normal mobility. Is just not just we are using a vehicle just not for mobility. We are using for a different purpose. So the one of the main technological improvement we are looking into the autonomous vehicles, where the individual can decide to move from one place to another place without the intervention of the driver. That is the main idea of using autonomous vehicles. And some of the motivation points are the in some of the literature we got that within the 10 years we have fully autonomous vehicles will be the norm, and 10 millions autonomous vehicles will hit by 2030. And widespread adoption of autonomous vehicles lead to 90% reduction in vehicle crashes, accidents, and violating the rules. All those can be avoided if you use an autonomous vehicles. So many autonomous functionalities are required to as a autonomous vehicle. The one of the functionality is lane change assistance. As a vehicle, autonomous vehicle, when it changes the lane, when it has to change the lane, it has to perceive the surrounding area. It may be an object, it may be a vehicle, it may be a pedestrian, anything. So we need to, as a autonomous vehicle, it has to perceive all the surrounding objects. That's why this topic is the technology will help the vehicle to assist the to take the lane change. So there are different types of automation according to the SAE levels. It starts from 0 to 5. The 0 means it is a no automation, that is in the olden cars. The driver is the ultimate one who has to control everything. But as it moves, the SAE level 1 driver assistance, some of the functionalities are automatic and remaining things is controlled by the driver. As we move on, if it is the third and fourth automation, highly automation, that means everything, perception, everything will happen using the sensors, and electronic ECUs manage everything. Driver just is a part of the vehicle and he has the control of a vehicle. And the fifth level is highly automated. These are the SAE levels we are looking into that. Then autonomous vehicle, some of the advantages, we can reduce the emissions, then we can support the zero vision, that is for driver support, and we can avoid the accidents, and we can improve the economy, and you can use the maximum percentage of sensors, actuators, and we can reduce the cost effectiveness, that is nothing but the maturity of driver assistance systems into the autonomous vehicles. So from this, we can come out with the objective, that is the develop lane change assistance system using LiDAR and detect the sideway objects with its distance, and establish a communication to ECU via CAN protocol. So this is the platform where we are implementing this lane change assistance system. This is we have taken using a nano car, where we are putting different sensors, LiDAR, radar, the 2D LiDAR, radar, and IMU sensors. In this lane change assistant, we are using TF02 LiDAR, which will help us to detect the sideway objects. And the electron architecture, we mainly classified into three categories. First one is sense, plan, and action. or actuate. The sense means it is a sensing the environment with the different parameters or different variables. So it might be radar, lidar for different applications. So one of the sensor which we are using in this book is the lidar. It is light detection and ranging, where it will detect the objects. The purpose of using the lidar is the detect the objects. There are different means we can use. The radar, camera, and lidar can be used, but when you use the camera, the main constraint of a camera is the computational complexity is more, and it takes more time, more memory is required, and a high-end processor is required to do the computation. Therefore, the computationally efficient and low-cost option is the lidar.
Sorry to interrupt you, sir. Please go ahead with the closing remarks.
Okay, okay, sir. So like that. So this is the block diagram, and we are using Cortex M3 and lidar 2. The output of the lidar, we will get a 9 bytes of data, and out of that, byte 2 and byte 3 are the distance we will get it from the lidar. Once we get the distance, based on the distance, we can calculate if it is greater than threshold. We will identify that there is an object in the sideways. From that, we can decide whether I need to take a turn or not. That is how the system will guide the vehicle. So these are the different obstacles we have experimented, and we are getting the percentage with a different accuracy. From this, we can conclude that the proposed method efficiently detect the objects in the range of 85% to 97%, and this feature will assist the driver for easy lane change, and this autonomous or